This is our lesson on direct variation. Chefs would use direct variation to determine ingredients needed for a certain number of servings. Environmentalists could use it to determine how many dunes that would need to be built when you have those coastlines that are eroding away because of the storms. Direct variation can be confusing. It's a special kind of linear relationship that can be written in the form y equals kx. Kind of looks like y equals mx for those who have seen y equals mx plus b. K is a constant, and it's called the constant of variation. And this is kind of confusing because constant means the same, but variation means it changes. So I want you to think of this as like your rate of change. And let's move forward. Now, it cannot be 0. That's one clue. The equation y equals 2x describes the relationship of servings to shrimp. Notice that your shrimp would be your x and your servings would be your y. In the recipe below, the number of servings varies directly with the number of ounces of shrimp. So think about, where have you seen y over x or y divided by x before? This is the same thing that we're going to be talking about with direct variation, but there's a twist. So how do you identify a direct variation from an equation? The key is the equation must be able to be written in y equals kx form. Remember when we were doing standard form, we talked about ax plus by equals c. Now we have this form here, y equals kx. Y equals 3x is direct. It's a direct variation. Y equals 1/2 x is also direct variation. But so is this, negative 3x plus 5y equals 0. This is standard form, but why do you think it's a direct variation? Let's take a look across the way and look at the ones that are not a direct variation. Y equals 3x plus 2. 2x minus 4 equals y. 2x plus y equals 10. What do you observe? What is happening on this side that you are not seeing on the left-hand side? Now, some of you may have noticed that you have these numbers here, the 2, the negative 4, and the 10. But you also may say, well, I see a 0 over there, just like, it's both standard form like these two, but that's got a 0 and that has a 10. The thing is, the 0 can go away. If we wanted to take negative 3x plus 5y equals 0 and put it in y equals kx form, all you would have to do is add 3x to both sides, and you would have 5y equals 3x, and then y equals 3/5 x. That 0's gone. If you try to do that over here and move this 2x over here, you're going to get negative 2x plus 10. That number is not going away. So what's happening on this left-hand side is with or direct variation, there are no c values. Sorry, this is messy. There are no c values. There are no constant variations. There's no what I call plain boring numbers being attached. These numbers in red that I circled on the right, they don't show up on a direct variation. Let's take a look at the examples down below. 3y equals 4x plus 1. 3x equals negative 4y, and y equals 3x plus 0. That's a direct variation, and that's a direct variation. That's got a 1. Cannot have that extra number. That 0 is going to go away. And here we can divide by negative 4 and get 3/4 x equals negative 3/4 x equals y. So this is the key that we're looking for, is that constant, that other number, that c value on the end. And we're just going to do a little bit of a discovery here. So let's take a look at the formula y equals kx. If you solve for x, let's see what's happening. Y equals kx. Solve for k. Just divide both sides and this is what I talked about on the earlier page. Y divided by x is k. Remember, rise over run is the same as your change in y over your change in x. And k basically is your slope. It's the same thing as m. Why don't they call it that? Well, because we're talking about a direct variation, and a direct variation does not have that number tagged on to the end. It's just simply y equals kx. It's not y equals kx plus 4. And that's why you have to have the difference between the k and the m. So how do you identify a direct variation from a table? Here's a table. Is it a direct variation? Well, there's two ways you can look at it. You can try to write the equation for it. Let's see. We have plus 2 here, plus 2, plus 2. All right, we got a common difference there. We have plus 12, plus 12, plus 12. Common difference there. Then we have right here, 1 times 6 is 6, 3 times 6 is 18, 5 times 6 is 30. So it looks like we have y equals 6x. That's one way we can look at it. Other way we can look at it is go back to the y over x. So we have, this one is right here, 6 divided by 1, 6. 18 divided by 3, 6. 30 divided by 5, 6. 42 divided by 7, 6. They're all the same. It's a direct variation. Yes. It is a direct variation because y divided by x is 6. It is constant. It's the same. Let's take a look at this one. We have plus 2 plus 4 plus 2 don't really have common difference here. Here we're going down. This is not working. So let's see, the equation here we have is y equals x minus 4. Yeah, 10 minus 6 is 4. 8 minus 4 is 4. 4 minus 4 is 0. It's not a constant because we have that minus 4 there. It's not a direct variation. The other way we could do it that I think is actually a little bit easier, I'm going to erase this so we can see our work a little bit clearer. Sometimes coming up with the equation here is a little bit harder, so I'm just going to look at these y over x relationships. So let's take a look at this. We have negative 2 over 2 is negative 1. We have 0 over 4 is 0. We have 4 over 8 is 1/2. They're not the same. They're not constant at all. So because they aren't the same, this is not a direct variation. So now here we're going to write and solve direct variation equations. First example, the value of y varies directly with x, and y equals 6 when x equals 12. Find y when x equals 27. That's a lot of stuff there. This beginning part here is they're just telling you it's a direct variation. And when they tell you that, you're just going to remember, okay, I know that it's going to be y divided by x, so I'm just going to set up some equal fractions. But this is where you need to be careful. It says when y is 6, find y. And the reason I'm color coding is so I can keep everything in the right spot. So I have y is 6 when x is 12, so it's 6/12, 1/2. Now we have to find y, make sure you keep that on top, which is why I'm color coding. And now x is 27. So it's basically 6/12 equals what over 27? Or you can think of it again as 1/2. I'll just write it over here. 1/2 equals what over 27? And 2 goes into 27 13.5 times, or 27 divided by 2 is 13.5. So y must be 13.5. Take a look at the next one. The value of y varies directly with x. Again, all this is telling you is that it is a direct variation. You're going to get tired of writing y over x, but I strongly suggest it so you keep your values in the right spot. We have y is 3. Find y, so I'm going to write that there. X is 9. X is 21. I'm going to simplify 3/9. I'm going to write that over here. It's going to become 3/9 is the same as 1/3. 3 times 7, 1 times 7, y equals 7. Last example, y over x. Setting up my fraction bars. Y is 4.5. Find y when x is 0.5 and 10. Will there be times when they're going to ask you to find x instead of y? Yes. Just make sure you put your y's on top and your x on the bottom and read this carefully. So go ahead and work this one out, and I'll give you a minute. You should have gotten that y is 90. Now the last part here, this is writing a direct variation equation from an ordered pair. So here you have 2 steps. So the first thing you need to do is remember that your equation is y equals kx. And if you remember from the other page, k is nothing but y divided by x. So, then I wrote that right there. You have 2, 10. We have y over x. So there's your y value, 10, divided by 2 is 5. If you remember from right here, 5 is k. So now you're just going to take that 5 and just plug it right over into the k, and you're going to get y equals 5x. Because that's the only way that you can get an ordered pair of 210 if y is 5 times x. So take a look at your 210. Remember, 2 is your x. 5 times 2 is 10. That gets you your y. It's just like taking a table and deconstructing it. Let's take a look at the next one, 8, 2. So remember, k equals y divided by x. So we have 2 divided by 8. It's perfectly fine to have a fraction. That's going to be 1/4. That's k. So now you have y equals 1/4 x. Okay. Let's go back up here. We have -3, 9. So k equals y divided by x, which is the same as 9 divided by -3, which is -3. So y equals -3x. Now we have 5, 1. So basically it's 1/5 equals k. Y equals 1/5 x. There's a lot to remember here, but if you just try to think of it as your y equals mx, when you've seen that before, and that when you have your table, when you have your ordered pairs in a table, you need to be able to have an equation to get you from that x to that y. So in the case with the 2, 10 and your equation of being y equals 5x, you can always go back and double check your work. With the problem right here with the -3, 9, that's your equation. -3 times -3 is +9. It's all going to fit.